All right, so today we are doing the sum and difference of cubes. So yesterday we did the difference of perfect squares, and they have a similar look to them, but instead we have cubes, and we could have a sum and a difference. So just as a reminder, sum means to add or is a plus sign, and difference means to subtract or is a minus sign. So, and a perfect cube is the result of 3 of the same number or variable multiplied together. 3. So perfect square was 2. So these are the differences, and let's see if you can notice it from here. So when we do this problem, we have to identify the perfect cubes. So a perfect cube here for 1 is a perfect cube because it's 1 times 1 times 1. And the root of this perfect cube is 1. It's technically called the cubed root, but whatevs. Okay, 8 is 2 times 2 times 2. So you see this pattern. It's always one number multiplied itself, and we're going up by 1 to create some sort of list. So the root here is 2. So you have to know where the 8 comes from. 8 is 2 times 2 times 2. 27, you guessed it, 3 times 3 times 3, and its root is 3. 64. 64 is interesting because it's a perfect square and a perfect cube. When it's a perfect cube, it's 4 times 4 times 4, so its root is 4. So that's an interesting one to remember. 125, 216, 343, 7, 8, and 9. So we see a lot of these. Most commonly, we see, up to at least 343. You can always just do the cubed root in your calculator to see if it is a cubed root. And we'll go over that in class if you don't remember how to do it. When we do letters, you'll remember that if it was even, it was a perfect square, the exponents. So I wonder if you can see how it works here. So x to the third is x times x times x. So the root is x. Okay. To the sixth is x squared times x squared times x squared. That's x to the sixth, and x squared is the root. I should have had a column for that here. Okay, x to the ninth is x to the third, x to the third, x to the third. So the root is x to the third because you multiply that times 3. Remember what we're doing is we're adding exponents because we're multiplying bases. So we add the exponents up. That gives us the 3. And so since the same thing over and over, that's the root. One of them is the root. So x to the 12th is x times x to the 4th. So the root is x to the 4th. So let's see. All of these guys, what do you notice about the exponents of all the perfect cubes? Well, it's 3, 6, 9, 12. Hopefully you can see that they're all multiples of 3. Or they're divisible by 3. That's all what you say. Either way you think about it, that's the way it is. So the root then, what about its cube root? Its cube root, so we went from 12 to 4, 9 to 3. What is the cube root, you think, of x to the 15th? Well, it's x to the 5th. We do that by dividing the exponent by 3. So they're always multiples of 3. So if we divide it by 3, you're going to get the one piece that we need. So this would be x to the 6th. This is x to the 7th, x to the 8th, and x to the 9th. All right. So then to do this, unfortunately, is not as simple as dots is. It's like a whole process. And you just have to get the process down. It takes a little while, but once you get the process down, it's the same every time, and it's super fun. Okay, I lied. It's not fun. So it starts off with the same basic way we did the sum and difference of perfect squares, where you take the cubed root. So each of these pieces, these are perfect cubes, here and here. This is an example of the sum because there's a plus sign here. And this is an example of the difference because of the minus sign. Okay? And then there's parts to it. We have right here, us teachers lovingly call this, sorry, the little cheek and the big cheek. So when you do difference of perfect squares, they're both little cheeks. But here we have a little cheek and here we have a big cheek because we have a binomial and a trinomial. And the way that this works, I'm just going to show you with an example. The formula is nice, but I think an example might help you better. So just like we start out the little cheek the same way we did a perfect square. But in this case, since they're perfect cubes, we're going to take the cubed root of them. So the cubed root of a cubed, so what's the root of a to the third? Well, that was a. You take the exponent and divide it by 3. And the cubed root of 27 is 3. Do the cubed root in your calculator. Look to the top. It's up there. Okay? Sorry, I'll show you. The cubed root is 3 right here. 27, the cubed root is 3. Okay? That starts out the same. The difference here is, I'm going to make this one blue so you can see what happens. So what we do here is the second one, the big cheek, is a little bit more involved. You have to take the first one and square it. And then that's the first spot. The second spot here is we multiply these two together. So it's 3a. And then the third piece is you square this one. So if you think this is the first one, this is the second one in this piece. You square the first, multiply the first and the second together, and then square the third. Okay, that is the most difficult thing to remember. So we have to kind of really concentrate on it when we're thinking about it. Okay, so then it's squared, multiplied, squared, multiplied, squared. And then we say, don't be nasty, use soap. What does that mean? Don't take it the wrong way. Okay. These are when we're talking about the signs of this. So we don't worry about the signs until now. Once all the terms are in, then we think the first one here is the same as the original. Same. The second one is whatever the opposite is. So this one was positive, so it changes to negative. And then this one right here is always positive. So it's same, opposite, always positive. It spells out soap. Yeah, I know you're excited about that. Don't be nasty, use soap. All right, so let's just do this one really quick. So starts out the same. The little cheek, take the cubed root, take the cubed root. So it's a and 5. All right, then these parentheses, it's squared, first one squared, multiply the two together, last one squared. Then same, so it's minus sign here, so this is minus. Then switch to the opposite, and then always positive, and that's it. So this is a process that you have to memorize, and I know you haven't seen it in a while, so you may not ever have seen it before. So there we are. So here we go again. Little cheek, big cheek. Cubed root, square, multiply them together, square. Same, opposite, always positive. Okay, so you can get that quick, but you need to, think about it first. So here we have just a whole mess of stuff, but they're all perfect squares. Perfect square, perfect cube, perfect cube, perfect cube, perfect cube. Because we have even exponents. Oh my God, Miss Barris, thank goodness no one actually listens to me, because I feel like I'm going insane. They're multiples of 3. Okay, so we take the cubed root of 125, so that's 5. The cubed root of x cubed is x. Cubed root of 27 is 3, and y cubed is y. These guys go together because they're together, and these guys go together because they're together. So those are the first and the second. That's the little cheek done. Now we just take those pieces and we square the first one, multiply them together, so 15xy, and then the last one squared, so that's 9y squared. And then it starts with a minus sign, so this starts with a minus, plus, plus. Same, opposite, always positive. Okay? Awesome. So I just want to quickly talk one more. I know you're like, oh, I thought it was done. Because I didn't do anything with x to the anything. So if I talk about, like, say, x to the 9th, you can do this. Minus, let's say, 343 y to the 15th. So let's just see if you can do that one. So little cheek, x to the 9th. The little one is you take the exponent divided by 3, and that goes there. Same here, exponent divided by 3 goes there. The cubed root of 343 is 7. So that's the little cheek. The big cheek, now you just have to square these. X to the 3rd squared is x to the 6th. Multiply them together, so you get 7x to the 3rd, y to the 5th. And then square 7y to the 5th, we get 49y to the 10th. And then same, opposite, always positive. So just a quick example of how amazing you are and all the amazing things you're going to do soon. All right, have a great day.